All right, class, let's jam with it. We are in, or starting 7.3, the law of cosines. Let's see, I think we did law of sines already. So let's do this here. I'm going to try, let you guys try an example. Oh, real quick, let's review first. Law of sines, remember, is, because it's been so long already here. Law of sines looks like this. It's the relationship between an angle and its opposite side, and all the angles in its opposite side in a triangle are always proportional to each other. That's such a cool thing to have. Like, that is awesome. So that's the law of sines. So notice you need an angle, you need an opposite side, angle, opposite side in order to make this work. And then if it's a C angle, same thing happens. Of course, let's check this out. So can you guys solve using the law of sines this problem right here? So let's go for it here. So I'm going to make a little triangle like that, non-drawn to scale whatsoever. So let's go with it here. So it's angle A, or triangle ABC. And we have, let's see, this is 60 degrees. That's going to be, so this is little b. Little b would be across. That's 25. And little c would be right there. So let me erase those. But here's my little triangle right there. Okay, question, can we use the law of sines here? Go. Well, the law of sines says I need an angle and its opposite side, which I don't have. And then I'm missing the other two angles. Not good. Oh, okay. Got a little problem. Okay, in 7.1, you never had this situation. We got all in 7.1, all the triangles worked out so well, and it was so perfect. There was no problem there. Now here's our problems. Okay, so if by maybe, just maybe, if we did not even know the 25, but we know this to be like 70, if we had that situation happen, then we could have found this angle here, and then we would have had an opposite side. So that's no problem. So if we had two angles, it would have been fine because we can always find the third. If we knew what this one was, let's say it's 41. Okay, if we knew what that was, then yes, we could still use the law of sines. But in this situation, no, can't use it. Hey, you know what? Let's go back to geometry, your geometry days. This would be, do you guys remember on setting up congruencies? This would be the sine angle side, or side angle side. If you think about it, right? You know the side, you know the angle, and you know the adjacent side. This is a side angle side problem. You know, let's do a little bit more work here. If I knew this right here, could I solve for the law of sines? This would be the angle side angle. Oh, that's so cool. So notice, if an angle side angle, I could use the law of sines. So law of sines, I can use angle side angle. What's another typical scenario I can use the law of sines? Let's see. If I knew this one already, could I use the law of sines here? Oh, this is the ambiguous case. That's right. This is the side angle. Okay. All right. And as opposed to getting into the weeds of this here, let's actually go through. In your textbook, you do have, let me actually skip number 2 for now. In your textbook, you do actually have all the different cases. So we might as well look at it here. So on page 338, you do have a delineation of all these. So if you have an angle case, none of the methods work. The law of sines, law of cosines does not work, because angle case, there could be infinite number of similar triangles. It can't have. Okay, something that we were looking at today, the law of sines would work if you have two angles and you know some kind of side there, or if you knew two angles and the side that was in the middle, that would work. And in any case, you need two angles because you need to somehow get to the third angle right away. Okay, that's the law of sines from 7.1. 7.2, which we're going to do today, is the law of cosines. If you're in this situation where you see two adjacent sides and the angle in the middle, or if you know all three sides, you have to use the law of cosine. Okay, and the ambiguous case. The ambiguous case is when you know side-side angle. So remember, this was like this. We knew this side, we knew this side, and we knew this angle. And we went from there because that was, could be 0 triangles, could be 1 triangle, could be 2 triangles. So that we were dealing with in 7.2. Okay, let's back up just a little bit here. Let's go to here. So all yours, please set up the triangle. And of course, you just might get stuck. Give you guys a few minutes here. Set up this triangle. All right, hopefully did. So I just know sides here. That's it. So this is angle A, angle B, angle C. I know little a to be 13 feet. I know little b to be 14 feet and 15 feet. And you know what? The law of sines does not work. Okay, so hence the law of cosines. So let's go for it here. So let me pass through all this. Let me jump to this. Let me actually give you the law of cosines already. This is form 1. So there's one form where we are solving for the opposite side of the angle. So notice this little relationship right here. It's always the cosine value of A gives you A squared. Cosine value of B, or cosine value of B here, gives you B squared. Cosine value of C gives you C squared. So it's the side angle side issue. If you have that issue, you're going to use this form, easiest form. It's already there. And we are actually going to derive, let's derive this one right here, because all the rest of them derive exactly the same way. We'll have to like, hey, you know, we're going to create this form. That's cool. All right, the other form is just taking this and putting it in a different way. So let's take the first one right here. So if I were to solve this for, if I were to solve this for the other, you would just subtract b squared, subtract c squared over to this side. Then I have a squared minus b squared minus c squared is equal to a negative 2bc cosine A. Divide through by negative 2bc. And voila. Oh, you know what? We have to change all the signs here. So when I divide the negative 2, bring it to the top, the a is going to be negative. The b squared is going to be positive. C squared is going to be positive. That gets rid of that. And I'll keep the 2 on the bottom. So let's see if this makes sense. So this is going to be cosine A is equal to b squared plus c squared minus a squared over bc. And that is when we're trying to find the angle. So boom, there it is. There's that little derivation right there. Okay, and again, this is when we know all 3 sides. Notice all 3 sides go into a formula, and out comes a cosine of an angle. And that's what we solve for. We solve for angle A or angle B or angle C, whichever one we need. Now, real quick here. Ding, 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 ding. Put it aside here. When you choose, and especially in this case, when you choose the largest side to solve for, you want to choose the one that's going to give you the biggest angle. Always choose the biggest angle. And how do you know how to choose for the biggest angle? It's always opposite the biggest side. Okay, it's always opposite the biggest side. Okay, let's jam. Let's derive this guy. So the derivation of the law of cosines, because we're cool like that, we can derive this. Let me draw it a little bit better here. Draw it like this, like this, like this. There's my angle A, B, C. You know what, let me, real quick here. Sorry, let me just switch these two. Just a little easier to see. So I'm gonna go A, B, C, like that. So that's my triangle. All right, what we're gonna do is we're gonna do 2 things here. We're gonna drop hypotenuse down. We're gonna draw a little line right here. And we're just going to call it h. That's what we're going to try there. All right, so as I look at this here, so first things first is little a is going to be over here, a little b is going to be over here, and then c actually gives this little context right here. It's this little piece right there. All right, hold on, class. Let me do this let me change something up real quick here. All right, we're going to derive the law of cosines, and I'll fill in the beginning. So first things first, let's see. Give me a cosine of a. What would that be?
Well, it'd be some portion of C over B, right?
I tend to think so. So now we have to put it then together to see what happens here. How funny. I wrote it wrong in my sheet of paper, that's why. Okay. If we have that, I think I'm going to use this little guy's x then, because I don't know what it is, right? If that's x, can I flip it around? What would this part be right over here? I'll go with that, c minus x. Got a few more things labeled. That's awesome. Okay, let's jam with it then. Now can you give me cosine of a?
X over b.
X over b, everybody agreed there? Let's see, what's another thing we can do? Let's multiply both sides by b. I got myself b. Cosine of a is equal to x. That's cool. What's some other stuff I see? You know, I actually see two different Pythagorean theorem equations. One is this little small triangle here. Right, is that okay to put? Let's see, x squared plus h squared is equal to b squared. That's one. Good there. Give me a next one. I go with that too. That's awesome.
Wait, sorry. In the first one, the b cosine a x over b, was the b already there? Like, how did the b get there?
Little b?
Yeah.
Yeah, it was already there. It's part of the triangle itself, because that capital B is one angle, right? So its opposite side is going to be little b. Across. Talk to me, Farina.
Wait.
Should this little b right here?
Yeah.
Yeah, that was part of my angle to begin with, or my triangle to begin with.
No, yeah, but with the equation, why is the b in front of the cosine a?
Ah, gotcha. That'll be used for later, but primarily we want to get rid of x somehow, because x is our new variable that we put into it. Because we put in a variable into it.
My question is about the upper one, where it says b, yeah. So is the first equation cosine a? Okay. Sorry.
There you go. Yep. I got what you're thinking.
Thank you.
All right, and then there's some fun stuff to do now. So let's move things around just to make it work the way we want it to work. And so eventually we're arriving with that little formula that we had before, right? Let's see. I'm going to solve this guy for h here, because I want to get rid of h as well. H is another variable I put in myself. We're good? So x is a variable I put in myself. H is a variable I put in myself. So let's get rid of that one. H squared now is going to be b squared minus x squared. And move it over. And notice, if you guys think about it, notice it's kind of like an algebra 2, when you guys had 3 different equations or 3 different unknowns. We kind of have the same thing here. Here's one equation, here's another, And here's going to be a third one that we're just trying to figure out how to put together. Okay, this guy solved for x. Eventually I want to get rid of this guy. This guy solved for h, my new variable. I think I'm good. Let's start unwinding this one. In fact, let me...
So we're not solving for h, we're just solving for h squared.
H squared, at least for now, because I see an h squared over here that I'm going to substitute eventually. So c minus x to the second power, let's see, I think it's going to be c squared minus 2cx, tell me if you guys agree there, plus x squared plus h squared is equal to a squared. Yes, no, maybe. And I think the rest just might work out. Let's see. Let's plug in our h squared now, and let's see what happens here. So this will be c squared minus 2xc plus x squared from my original. Then it's going to be plus b squared minus x squared is equal to a squared. Tell me if you guys are okay still with that. We can drop our parentheses. I just kind of like to put in parentheses if I'm putting in stuff into equations here. Okay. Talk to me. You tell me what you see.
Well, there's a positive x squared and a negative x squared.
Absolutely. I see those guys gone. So how about c squared minus 2xc plus b squared is equal to a squared.
And then x is equal to b cosine a, so can we plug that in?
Absolutely, I'll go with that here. So that guy turns into c squared minus 2. So we have b cosine of a, that's what I plug in here, times c plus b squared is equal to a squared. Flipping it around, or no, it's simplified. Let's see, because the formula in the book is a squared is on the other side here, so I can do that. Let's see, I'm going to flip a squared to this side. And let's write in alphabetical order. How about b squared goes first? I got this little c squared that's on this side. And you guys tell me the end here. It's a minus what?
Two bc cosine a.
Okay, are we good? There it is. Awesome. Derived and everything. We just created a whole new law in trigonometry. Okay, so let's go back real quickly here. So the different formulas are, you can see the Pythagorean theorem inside it each time. And it's always this small side and the cosine of the other small side. It's always a minus 2. And it's the other two sides multiplied together. Are we good? So Pythagorean theorem, subtract twice each of the remaining sides, and it's cosine of the side that you're trying to find. If you want to write down all of them here. Okay, this is down. Let's finish off what we didn't finish off earlier. We have example 1 that we got stuck on. So let's finish it off now. Oh, let's see. Some of you guys are writing down all the formulas. Go for it if you like. Okay, and then I'm going to put one little extra caveat right here. We're going to use the law of cosines to find the obtuse angle. So whenever you're trying to use the law of cosines, what you want to do is you want to get the biggest angle possible, especially if the angle is going to be above 90 degrees in our triangle. That's what we want to find, if it's a choice for you. Go for it. Okay, let's finish off the first example that we started off with. So let me go. Ding, ding, ding. We got stuck with this one. Is that right? We had like this. It was ABC. You guys talk to me. Is that the way it was right here? Yeah, this was 60 degrees here. This was 25 there. This was 32, and we were stuck. We were trying to find little a technically, right? So all yours.
Little a is 849.
Oh, awesome. Okay.
I need, so please verify that for me. It seems absurdly large.
I second.
You don't have your calculator out.
And so this case, yes, when you use your calculator, there's you're going to have to use it in pieces because these are large numbers here. Cosine of 60 degrees after that here. So I don't know which one you want to write down first, or if you have a TI, of course, they're going to do all of it for you at one step and then take the square root out of it afterwards here.
All right, taking the square root, so that is, in fact, why the number is so large.
Da, 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 da.
It's actually like 29.1.
Okay, we got 29.1. What did you get for a squared again? 800.
849.
49-ish. Okay,
What did you get? Oh yeah, I got that too.
awesome. Okay, little a is 29.1. So now the question is, can we use the law of sines now? Absolutely. Finally found a side. So now it's going to be sine of 60 degrees over 29.1 is equal to, and then let's choose a side. For law of sines, what you want to do is you want to choose the side that's the smallest, or if you know for sure it's less than 90 degrees. And so in this case, if I was going to choose a side just in case, I would start using side B. I'd go sine of B over 25. And give me that one, because we should know how to do that one here by now. Multiply both sides by 25. So 25 times sine of 60 degrees divided by 29.1, and then take the sine inverse of it. What do we have?
48.1.
Okay, 48.1 degrees. Awesome. Okay. So for law of sines, use law of sines to
Wait, we're
solve.
finding C2.
Yeah, eventually here. To solve for acute angles. Again, did not come up to us in 7.1 because we're doing very elementary stuff. Notice if you're going to subtract for 180, what do you get for angle C?
What was your question?
As you subtract from 180, what do you get for angle C?
71.9.
Anybody second that?
Can I second this?
No. Yeah, okay, cool. Okay, and then almost done. Let's do law of sines to finish off. Oh, we're done, right? Sorry, we are done right there. So whenever you do a law of sines, you want to solve for the smaller angle. And the reason for it is this right here. Notice whenever sine goes around the unit circle from 0 to 180, sine is going to be the same value in quadrant 1 as it is in quadrant 2. So when you do sine inverse of a positive angle, it only works in quadrant 1. But in a triangle, you could have angles that are more than 90, right? And so that's, you got to be sort of mindful of that. So sometimes if you get stuck on the homework, like, why is this not working out? That's the problem, most likely. Okay, and there's the intro to it. We haven't done the examples with it here. Let's see, I think we're going to stop there at that point. Stop here. We'll come back to it on Friday. We'll do this one and we'll do the examples. Have fun being in the 1990s and enjoy the rest of your day.